Hello and welcome back to Maths Made Easy. Today we are going to start second exercise in chapter 7 of class 12. Detailed solution with explanation. In this lecture we are going to cover question number 1 to 10. Further we are going to solve in other lecture. By the way, here are some basic result in integration which you can take the screenshot if you want. There is a quick tip. When the result is starting with C, with that I mean cos, cot and cosec, the result is always negative. Many of them might not know about this. Sin, the result is cos. Similarly, cosec is minus cot. Anywhere, when you see there is a result starting with cos, cot, cosec, it's always negative. So just keep in mind, this is going to be very helpful if somebody forget about the signs. Okay, exercise 7.2, integrate the function in exercise 1 to 37. The question is 2x divided by 1 upon x square. Okay, the second exercise of chapter number 7 is totally based on the idea of substitution. We are going to substitute any of the values to make our question look simpler. So in this case, if you see, we have 1 plus x square, and we know that the 1 plus x square, whenever you find derivative of this, you will get 2x, because the derivative is always nx raised to n minus 1. So in this case, I am going to substitute 1 plus x square as t. Let 1 plus x square is equal to t. Therefore, I have d upon dx of 1 plus x square is equal to d upon dx of t. Therefore, I can write derivative of 1 is 0 and x square is 2x is equal to dt upon dx. So basically, I can say that 2x dx is equal to dt. Whenever we substitute anything to t or any other variable, we are always going to reach this situation. We have to get our numerator with dx to be replaced with something different in other variable. So our question is like this: 2x, I'm sorry, let me cut this one. 2x dx divided by 1 plus x square. So you know that 2x dx can be replaced with dt, and x plus 1 plus x square is t, as we have already assumed here. So this is equal to dt upon t. Now, if you remember the previous slide, the formula 1 upon x is always log x. When we integrate 1 upon x, we get log x. So here we can write log of t plus c. But don't forget to resubstitute the value of t. So our final answer is log of 1 plus x square plus c. I hope you got this question. Let's move on to the next one. Log x the whole square upon x. Okay, what you will substitute in this case? We all know the derivative of log x is 1 upon x. So our question is like this: log of x the whole square divided by x dx. If I substitute log x as t, I will get 1 upon x dx is equal to t. Let me show you how. Let log x is equal to t. Therefore, I can write d upon dx of log x is equal to t. I can also write 1 upon x 1 upon x is equal to dt upon dx. That gives me dx upon x is equal to dt. I'm going to substitute this over here. So I got dx upon x is equal to dt. In our case, dx upon x will be replaced by dt. So we have here t square dt. Now, x raised to n, integration of x raised to n, you all know this. T raised to 2 plus 1 upon 2 plus 1, that is t raised to 3 upon 3 plus c. Don't forget to resubstitute the value of t. So we have here log of x the whole cube divided by 3 plus c. I hope you got this question. Let's move to the next one. 1 upon x plus x log x. Okay, how will we handle this question? Let's take this x common first of all, because we all know that log x is 1 upon x. When we do the derivative of log x, we get 1 upon x. So when we take x common out of the bracket, you will see this question as like this: dx upon x 1 plus log of x. So in this case, if I take 1 plus log x as t, let 1 plus log of x is equal to t. So I can write d upon dx of 1 plus log x is equal to d upon dx of t. Derivative of 1 is equal to 0. So it is equal to 1 upon x is equal to dt upon dx. Finally, the value of dt is equal to dx upon x. So in this case, dx upon x will replace by dt, and 1 plus x we have already took as t. So what I have here is dt upon t. Now you know that it's like the first question. It is equal to log of t plus c, and don't forget to resubstitute the value of t, which is equal to log of 1 plus log of x plus c. I hope you got this question. We will be moving to the next one now. Sine of sine cos x. Okay, what will you do for this one? This looks like a complex. It's not only sine x or not only cos x or not only sine of ax plus b. This is something really little complex, or else you cannot think of what to do. In this case, we are going to substitute this cos x as t, because the derivative of cos x is equal to minus sine x, and we have sine x here. We can play around it. Okay, let's see. Our question is like this: sine x into sine of cos x dx. Let cos x is equal to t. So the derivative of cos x is equal to, I will do like this, d upon dx of sorry for this handwriting, d upon dx of cos x is equal to d upon dx of t. Now, derivative of cos x is minus sine x. Minus sine x is equal to dt upon dx. But we are only interested in sine x dx. See, I want to replace this sine x and dx with dt. So I am going to take this negative sign on the other side. So we have dt dt is equal to minus sine x dx. So our question will look like this: sine t dt with negative sign. integration of cos t is, integration of sin t is cos t. Since the result is cos or something with c, you can put negative sign there directly. Minus cos t plus c. This minus and this minus will become positive. So we have cos of t plus c. Don't forget to resubstitute the value of t, which is equal to cos of cos x plus c. I hope you got this question. Let's move to the next one. Question number 5. Sin ax plus b cos ax plus b. Now this looks a little tricky one because it is not direct substitution. We are going to adjust this question, so this become very simple for us. Let's start. Sin ax plus b cos ax plus b. What I did here, I multiplied my equation with 2 and divide with 2. Now this looks like a formula of sin a cos a, which is equal to sin 2a, 2 sin a cos a. So what I can write over here is integration of sin ax plus b cos of ax plus b can be written as 1 upon 2 outside the integration, this 1 by 2, and this 2 sin a x plus b cos a x plus b I can write in this form. So I have here sin of 2 times ax plus b. Sin of 2 times of ax plus b, because sin a cos a, 2 times of sin a cos a can be written as sin 2a. Taking this 1 upon 2 out of integral, we have to integrate cos 2 ax plus b. Now integration of cos, I'm sorry, I'm always confusing between cos and sin. Please for sin 2 ax plus b. Integration of sin 2 is cos 2, right? With negative sign. So what I will be doing here, minus cos of 2 ax plus b, and further I will divide my integral with the function, with the other function, that is, because here we have integral function, trigonometric function and algebraic function. Whenever I will be doing integration of the main function and dividing it with the other function. Other function is algebraic function. We are going to do division by derivative of the algebraic function, d upon dx of 2ax plus b. In here I will get only 2a because x will go by itself because it is x minus 1, x raised to 1 minus 1, and b is a constant, so it is also 0. 1 upon minus 4a cos 2 ax plus b is my answer. You might have noticed we haven't substituted anything here. We did not substitute. So that's why we don't have to resubstitute anything. Just we had did some adjustment in here. So the equation becomes simpler because this is already sin a cos b. If you go into the formula of u into v, which we are going to look in future, that may solve our question, but it will take a long time. It will take a lots of steps, and you don't have too much time to waste on if you have a simple option available. Okay, under root of ax plus b. This is very simple, and I'm not going to attend the entire. What you can do is here ax plus b power 1 by 2. Okay, now apply the formula of x raised to n, which is x raised to n plus 1 upon n plus 1. But the only one thing you have to keep in mind is this has a radical sign on top of it, which is exponent, that is 1 by 2. We will be writing integration for the exponential term exponential function, and then we will be dividing it with, okay, let me solve it. So in this case, our answer is integration of ax plus b raised to 1 by 2, which can be written as ax plus b power 1 by 2 plus 1, 1 by 2 plus 1, and then whole divide by derivative of ax plus b plus c. Ax plus b, it is going to give me only a. So I will just conclude it very fast. Ax plus b power 3 by 2 a, which can be written as 2 times 2 by 3 ax plus b power 3 by 2 divided by a plus c. I hope you got this question. We'll move to the next one. X root of x plus 2. Now here is something that you cannot do it by putting power 1 by 2. So let's substitute this with a under root of x plus 2. I will take x plus 2 as t. So I got the value of x, that is t minus 2. And at the same time, when you do derivative, you will find dx is equivalent to dt. So in this case, our integration looks like in x root of x plus 2 dx. So in place of x, what I will put here is t minus 2, and in place of x plus 2, I will be putting x plus 2 is equal to t. So t raised to 1 by 2, since it was a root. Now dt will be replaced by dx will be replaced by dt. So our equation looks like this one. You will be taking this 1 upon 2 inside the bracket. So this t raised to 3 by 2 minus 2 times of t raised to 1 by 2 dt. Now please use the formula n raised x raised to n plus 1 upon n plus 1 to further simplify this question, and substitute the value of t later and to x plus 2. X 1 plus 2 x square. Similar question, we are going to take inside term as t. So we have t outside, and we will be trying to replace this x either by solving for derivative or by direct substitution. Like in this case, we substitute the value of x directly. We did not make any derivative, because in case we go for derivative, x, the value of x will become 1 and 0, and we cannot replace x. But in this case, the value of the power of x is x square. When we take derivative, the power is reduced by 1, and in that case, we may be able to find the substitution for this one. So we will be trying that one. Let 1 plus 2x square is equal to t. So our derivative is 4x dx is equal to dt. But we are only interested in x dx. So I will be sending this 4 to the other hand. So x dx is dt upon 4. And then it's simple. X root of 1 plus 2x square dx. So it is equal to 1 upon 4 root of t dt, because x dx was equal to dt upon 4, dt upon 4. So x dx, I write 1 upon 4 and dt, and then inside the root we have t. This is just simple steps which you already know about it. And then we are going to substitute the value of t. Okay, 4x plus 2 root of x square plus x plus 1. In this case also, we are not going to directly substitute the value of x. First we will be finding derivative, and then we will try to replace x, because outside the bracket, see the difference in last 3 questions. The value of x inside the root, I will show you here. These are some indication. The power of x is same inside the root and outside of the root. So you can directly substitute. And in this case, in these 2 cases, the power of x was different. So in here also, if the power of x is 2 and the outside is 1, we go for derivative, because when we go for derivative, the power is already reduced by 1, and then it is very easy to substitute. So I have done the initial steps. From here you have to carry on. This is root of t, so you will be writing it as root of 1 up t raised to 1 by 2, which when formula is applied, it becomes t raised to 3 by 2 divided by 3 by 2, and then resubstituting the value of t, that is x square plus x plus 1. Question number 10, 1 upon x minus root of x. Okay, this one I will be solving. We are going to take root x common here, because x can be written as root x times root x. So very first step, we are going to take root x common. Okay. Now, when we take this one as t, you know the derivative of root x is 1 upon 2 root x. Keep in mind, when derivative of root x is always 1 upon 2 root x. So we are going to take root x minus 1 as t. 1 upon 2 root x dx is equal to dt. But we are only interested in root x. I mean 1 upon root x, dx upon root x. So this 2 will be shifted to other hand. So this becomes 2 dt. Instead of dx upon root x, I will be writing 2 dt, and then the question is solved. So this is our question. We took root x common, and then it can be written as 2 dt upon t. I will be taking 2 out of integral sign, and then we have dt upon t, which you can write log of t. Integral of 1 upon t is log of t plus c. So log of t plus c, resubstituting the value of t, that is root x minus 1 plus c. So I hope you like this video. If you did, then please subscribe to my YouTube channel, and I will see you in the next one. Thank you very much.